Hello everyone, this section is on interior angle sum of a polygon. Just to let you know, a polygon is a closed, right, plane figure with at least three sides that are segments. Now with these sides, the sides must intersect at their endpoints, or we could even say vertex. Okay, now what do we mean by closed plane figure? Well, if you look at this, this is closed because nothing on the outside can get in. So when we look at it, all of these segments intersect at their endpoints, right? They don't intersect each other, within the segment. The second one is not a closed figure because this is open, right? Nothing outside can get in. Now notice here, these two segments, right, do not intersect at their endpoints, right? They intersect, right, inside the segments. Therefore, that's not a polygon. Okay, so a convex polygon is a polygon that has no, right, diagonals with points outside the polygon. So if we draw all of these diagonals, they are all inside. Concave polygon is when one of the sides caves in, right? And if you look, it is a polygon that has at least one diagonal with points outside the polygon. So if I look, that diagonal is outside, that diagonal is outside. Therefore, that's a concave polygon. Now, generally, we name polygons by the number of sides. You guys probably know most of these, and we're only going to go through the common ones, right? A three-sided polygon, you should know, is a triangle. A four-sided polygon is a quadrilateral. 5 sides would be a pentagon. 6-sided would be a hexagon. 7 sides would be heptagon. 8 sides would be an octagon. 9 would be a nonagon. 10 would be a decagon. 11 would be decagon. 12 would be a dodecagon. Now, here's the thing. Anything over 12, we basically say it's an n-gon. So if it has 30 sides, right, we would say it's a 30-gon. Now, for this section, you do need to memorize these names. Now, an equilateral polygon is a polygon with all sides congruent. So we would say all of these sides are congruent. An equiangular polygon is basically a polygon with all angles congruent. So you would have something like this. Now, the most important one for this section is a regular polygon. It's basically a polygon with all sides and angles congruent. So you would have it be both equilateral and equiangular. Okay, so you guys have to know the difference between those words also. Now, a diagonal is a segment that goes from one vertex So it goes from a vertex to a non-adjacent vertex, meaning it doesn't touch a neighboring one. So this vertex, you could draw a diagonal there and there. You cannot draw a diagonal to these because those are adjacent. If I go to this vertex, I could get away with drawing this diagonal in this diagonal, if I go to this vertex, I have that diagonal, I have that diagonal. Okay, so a diagonal is a segment that goes from a vertex to a non-adjacent vertex. Now, the quick task here is interior angle sum of a polygon. What is the interior angle sum of a triangle? All the angles in a triangle add up to 180 degrees. So step 2 says construct a diagonal in the quadrilateral. How many triangles does the diagonal break the quadrilateral up into? So if I look, this diagonal breaks it up into one triangle and two triangles. So what do you think the interior angle sum of the rectangle is? Well, if I took all three of these angles, they would add up to 180 degrees. If I took all three of these angles, added them up, it'd be another 180 degrees. Therefore, the rectangle has an interior angle sum of 180 plus 180, which is 360 degrees. And if I move on here and I say, okay, use diagonals to create as many triangles as possible inside the pentagon without intersecting the diagonals. So if I pick one vertex to start at, I'm going to draw a diagonal there and a diagonal there. If you look, these two diagonals broke this pentagon up into 1, 2, 3 triangles. Well, I know this triangle is going to have angle measures of 180 degrees. This one would have measures of 180. This one would have measures of 180. Therefore, the interior angle sum would be 180 plus 180 plus 180, which is 540 degrees. So if I took this whole angle, this whole angle, this whole angle, this whole angle, and this whole angle, added them up, they would all add up to 540 degrees. Now, if I do the same thing for a hexagon, in this one, how many diagonals can I draw? 1, 2, 3. And it creates, right? I can create 4 triangles. 1, 2, 3, 4. What's the interior angle sum of each triangle? 180, 180, 180, 180. So I know the interior angle sum of this would be 180 plus 180 plus 180 plus 180, which is 720 degrees. Well, is there an easier way to do this? Because if I gave you and told you a polygon had 40 sides, would you want to find out how many triangles there are and all that? No. So what we're going to do is we're going to see that a triangle has 3 sides. You were able to construct one triangle, and the interior angle sum is 180 degrees. A quadrilateral had 4 sides. We were able to break that up into 2 triangles using diagonals for an interior angle sum of 360 degrees. A pentagon had 5 sides. We were able to break it up into 3 triangles, and the interior angle sum was 540. Now a hexagon, 6 sides, 4 triangles, right? And an interior angle sum of 720 degrees. There's 2 things, right, that we have to see from this. Can you derive a formula for the interior angle sum of a polygon given the number of sides n? Well, if I look at a pattern here, right, I know I'm basically, finding the interior angle sum by doing the number of triangles times 180 degrees. Right? Because if I look here, 2 times 180 is 360, 3 times 180 is 540, 4 times 180 is 720. But how can I find the number of triangles? Well, if I look even further, I will notice 3 sides gave me 1 triangle. 4 gave me 2 triangles. 5 sides produced 3. 6 produced 4. The number of triangles is equal to the number of sides minus 2. Therefore, we can say the interior angle sum of a polygon is equal to the number of sides minus 2 times 180. And we say n represents the number of sides. Therefore, we say it's n minus 2 times 180. That is the formula we're going to use. So if I gave you a decagon and I wanted to know what all the angles in a decagon add up to, I would take n is 10, right? So you have 10 sides in a decagon. So if n is 10, the interior angle sum would equal n minus 2 times 180, which ends up being 10 minus 2 times 180, and 8 times 180 will give you 1440. So if you were to draw a decagon and add up all the angles inside the decagon, you would get 1,440 degrees. Okay, so let's look at this. Find the sum of the measures of the angles of a 15-gon. Well, 15-gon, how many sides does it have? Number of sides is 15. So the interior angle sum would be 15 minus 2 times 180, and 13 times 180 would be 2,340 degrees. Now the next one says, find the sum of the measures of angles of a 22-gon. Well, 22-gon, number of sides is 22, so the interior angle sum would be 22 minus 2 all times 180. That would give you 20 times 180, which gives you 3,600 degrees. Now, the next question says, find the measure of each interior angle of a regular 18-gon. Well, here, the first thing we're going to do, we know the number of sides. We know the number of sides is 18. We can use that to find the interior angle sum. That would be 18 minus 2 times 180, and the interior angle sum, 16 times 180, is 2,880 degrees. Well, think about it here. Each interior angle now, if they're all congruent, each interior angle would be the interior angle sum divided by n, which is the number of sides. So each interior angle would be 2,880 degrees divided by, how many sides are there? 18. And 2880 divided by 18 would tell me each interior angle would be 160 degrees. Okay? Now, here, it's asking us to find the measure of angle x. Well, what you have to notice here, x and y are congruent. Now, even more important is if I took x plus y plus w plus z. What do all 4 of these angles have to add up to? Well, a 4-sided, if n is 4, right, the interior angle sum would be 4 minus 2 times 180, which we already said is 360 degrees. So we know all of those angles have to add up to 360 degrees. Well, if I take x plus y, let's just do this. If I take 360, I subtract 100, and I subtract 90. I took away these two angle measures. That's going to give me 270. Now, or sorry, not 270, 170. Now, if these angles are congruent, all I'm going to do is take 170 divided by 2, and you would get angle X is 85 degrees. Here, it says find H in the measure of each angle. Well, first thing I have to do is find the interior angle sum. Well, I know N is 4. So all 4 of those angles, interior angle sum, would have to add up to 4 minus 2 times 180, which gives you 2 times 180, which is 360. So I know H plus 2H plus 2H plus H equals 360. So that's 2, 4, 5, 6H equals 360. So H is equal to 60. Well, if that's 60, that angle's 60, that angle's 60. 2 times 60 would give you 120, and this would be 120. So, do me a favor, that's the end of the notes. Go ahead, try the homework, and let me know if you have any questions.